where you are in the world, I hope you get to enjoy day 2 of the PASS Virtual Summit.
There's so many sessions to watch, there's networking to be had, and there's virtual connections all over throughout the platform.
I've been at these PASS events for the past 20 years. I'm looking forward to just sharing a virtual space with people. The summit should still be an amazing place to be, even only giving virtual handshakes, high fives, and hugs to our SQL family.
Good morning, or afternoon, or evening, depending on where you're joining us from. I'm honored to be welcoming so many of you from all around the world for day 2 of our first ever PASS Virtual Summit. The conference has only just started, but I'm hoping you've already been able to learn some new skills, connect with friends, and get to know our sponsors and exhibitors. Everything we have available for you here today and throughout the event is curated to help you progress through your career. So please take advantage. It's no surprise that our organization was faced with one of our biggest challenges yet in fiscal year 2021 with COVID-19. This disruption made us reevaluate what was possible with our in-person events, including SQL Saturdays, local groups, and PASS Summit, as we pivoted to this new virtual world. It also reinforced the importance of introducing a new membership offering that would give members the training and engagement with PASS that they've been asking for, while supporting our organization's future through this revenue stream. Upskilling and maintaining personal connections is more important than ever, and this new membership facilitates that through an increased interaction with PASS. Over the past 22 years, PASS membership has grown to over 300,000 members. When I look back at where the organization was when I first joined, it's hard to believe how far we've come. We have members in over 200 countries and offer events that cater to a multilingual, diverse community. As Executive Vice President of Finance and Governance, it's important that I give you an overview of PASS's finances from this last year and acknowledge what's in store for fiscal year 2021. Every penny PASS raises is invested right back into our community to get you the resources you need to own your career. As you're all aware, this year has presented us with a huge challenge, including a deficit budget of $1.58 million for fiscal year 2021, due to the impact of COVID-19 and the move to a virtual conference. While we know this is a big hurdle to overcome, our focus remains on bringing the organization through this challenging time with the support from you, our members, and our incredible partners. However, today I'm here to talk to you about the position we ended fiscal year 2020 in, which helped us to mitigate the impact of COVID-19 at the start of this fiscal year back in July. Strategically, the PASS board works to evaluate the effectiveness of our fundraising efforts and our impact on the community. This is a key focus of everything we do. Over the years, we've invested heavily in the community, and I want to share a look at our revenue, expenses, and growth as an organization across the past 3 fiscal years with you. Looking back on where we landed from a financial standpoint in fiscal year 2020, we finished up the fiscal year with a $550,000 net income, achieved by a 2% increase in revenue and a 4% decrease in expenses. While this is a positive result and gives us much needed cash flow going into fiscal year 21, a significant portion of this resulted from major cutbacks in our expenses. Before COVID-19 was a reality, we had projected a small deficit in order to give us the funding we needed to achieve strategic initiatives and grow the organization. Thanks to a quick pivot and strong relationship with our management company, we were able to cancel outstanding contracts with no penalties and cut costs through significant concessions from our management company. This reduction in expenses, resulting in net revenue for fiscal year 2020, positioned PASS to support cash flow throughout the start of fiscal year 2021 as global economies and the normal cadence for how registrations flow into virtual events were impacted by COVID-19. Ultimately, we achieved a net profit margin of 6.5%. If the savings made through the reduction in the management fees hadn't occurred, our projected profit margin would have been a relatively flat 0.6% year over year. As we look back at previous years, it's clear that with the pivot PASS made, including the immediate reduction in expenses and our increased revenue throughout fiscal year 2020, we were able to achieve exceptional profit margins for the last fiscal year. So what does this mean for our community? Our membership continues to grow. Though COVID-19 affected our community leaders and organizers' ability to host in-person events like SQL Saturday in the last quarter, we still saw an increase in members by 3.5% year over year and 20% since fiscal year 2018. We know we have a long way to go before we fully realize the impact the pandemic has had on our organization. But looking forward, we are optimistic for the opportunities that we have to grow with the help of our community. Initiatives like PASS Pro membership will give our members exclusive access to tools that can help you accelerate your data career while giving you new ways to support the organization. We have also found new ways to work with sponsors with the addition of partner webinars and across events throughout the year. And when we look forward to growing these relationships with you for the years to come. Please take some time to visit our sponsors and exhibitors in the exhibit hall during the live video chat hours, or stop by at any time and leave a question. They're here to learn about your needs and to help you. By attending PASS Virtual Summit this year, each one of you are contributing to the long-term success of PASS. I'd like to thank you all for being here, and I hope you've already seen a glimpse of the value that this year's conference has to offer. We remain focused on the needs of our core membership, but we are also aware that there is a growing global audience of engaged members that need our support, and many are here with us for the first time today. We are also committed to ensuring that you are able to contribute to the ongoing conversations throughout the year and get resources you need to achieve your career goals. For more information on the PASS fiscal year 2020 financials, please visit the governance section of pass.org. Now, before I finish up here today, I want to take a few moments to thank all of the speakers, volunteers, sponsors, and attendees that have helped to make the PASS Virtual Summit a reality. This will be a conference to remember, and I encourage you all to ask questions, meet others, and enjoy everything that our virtual platform has to offer. It's now my pleasure to welcome to the screen PASS Director Chris Yates.
Thank you, Tim. And wherever you are in the world, welcome. It's fantastic to be here with you all today on day 2 of the PASS Virtual Summit. And I hope you've been enjoying everything the virtual experience has to offer so far. If you're tuning in on the PASS TV and haven't yet registered for PASS Virtual Summit, you're missing out. It's not too late to join in and secure your 12 months of on-demand access to everything PASS Virtual Summit has to offer. Now, I want to start off today by recognizing the heart and soul of our organization, you, the members. As a volunteer-led community, everything we're doing here today and throughout the year is only made possible thanks to the unwavering support and dedication of our members. Many of our members give up their free time volunteering, organizing, and speaking at SQL Saturdays, along with past local groups and past virtual groups around the world. This is a huge undertaking on top of your already demanding day jobs. So know that we see you, we appreciate you, and we thank you for all you do for our community. I'd like to give a special shout out to our outstanding volunteers from throughout the year. These individuals not only embody the spirit of what PASS is all about, but they have gone above and beyond to support their fellow members in their learning journeys. It's amazing to see how our community has come together to help one another during this challenging time. Whether this is your first introduction to PASS or you've been a member since day one, I encourage you to get involved and take advantage of the volunteering opportunities available throughout the year. By volunteering and connecting with your community, you're not only helping others, you're also growing your own skills, experience, and network in return. And one of the best things about attending PASS Summit is the networking opportunities. Since the conference started yesterday, you've been able to connect with leading data professionals around the world. Whether it's through our networking events, session QAs, in the community zone, the regional spotlights, or through fun events like Kilt Day, PASS Virtual Summit is your chance to meet peers and experts who can help you advance in your data career. So strike up a conversation, get to know your fellow attendees, and take advantage of this virtual experience. And with the shift to a virtual conference, we needed to be agile and change our approach to promoting and generating awareness this year to ensure that as many of our global members were able to attend as possible. For many of you, this virtual conference has enabled you to join PASS Summit for the first time at a much lower cost. Delivering the same exceptional experience and value of an in-person event for attendees was a huge undertaking by the entire team. And we're looking forward to sharing all the new features and networking this virtual platform has available for you here today. I'm also excited for the new ways we're celebrating diversity this year. PASS supports and embraces a diverse membership, and we're pleased to be welcoming a global audience over 3 days. And one of the things I'm most excited about is the introduction of our inaugural Diversity, Equity, and Inclusion Keynote, in addition to our incredible Women in Technology Keynote. So please make sure you join and support the WIC Keynote with Denise McInerney later today, and our DEI Keynote with Barrier Williams on Friday. Now, however, it's not only a PASS Summit that we want to do more to support our diverse and inclusive community. We also introduced initiatives this year to highlight the issues facing underrepresented groups in our community through our first PASS Diversity Panel. The introduction of a DEI virtual group, along with an updated PASS Code of Conduct. It's essential that our members always have a safe and inclusive space to connect with our community, and that everyone is treated with kindness and respect, 365 days a year. We will be continuing this momentum in 2021 and working with our community members to get it right. Now, as Wendy touched on in yesterday's keynote, this year challenges to move forward with the launch of our PASS Pro membership offering in tandem with the unexpected transition to a virtual conference. This was another big milestone for our organization, and we will be continuing to focus on enhancing this offering in the coming year. In October, we announced the launch of the PASS Educational Series as an added feature of the PASS Pro membership. This series is delivered by leading top experts. It consists of curated learning designed to take you to where you need to be in your career path. And in addition to this, we've also introduced the Microsoft Learn Bootcamp to help PASS Pro members to get their Microsoft Azure DBA Associate certification. And we'll be launching a PASS Pro training record next year so that you can show your learning progress and advance in your career. Now, PASS Pro membership is only $120 a year. So if you haven't already done so, please head over to pass.org to find out more and upgrade your membership, invest in yourself, and support the future of our organization. Now, of course, community feedback fuels every single thing we do as an organization throughout the year. The insights we gain from membership surveys, session evaluations, and through everyday conversations help shape our year-round priorities in the program at PASS Virtual Summit. So please take the time to complete your session evaluations over the next couple of days and share your thoughts. We will continue to consult and work with our members in the coming year to ensure your voice is heard. Myself and the rest of the board will also be available to chat at different times throughout the conference in the community zone. So please make sure you drop in to ask questions and discuss the future of PASS. A lot is different at this year's virtual conference, but we're excited to share all the new and innovative sessions the PASS Virtual Summit has to offer and give you a chance to virtually escape the challenges of the year and reconnect with your community. With our streams, spotlights, learning pathways, network bubbles, health and wellness breaks, and much more, there's a lot to keep you busy. So make sure you take advantage of your 12 months of exclusive on-demand access to catch up on any sessions and content you missed throughout the week. And now, I'm very excited to welcome our next keynote speaker, Hanuma Kodavalla. Today, Hanuma, along with some very special guests, will explore the technical innovations that have spanned the world of data for over 20 years. This is big. Please join me in welcoming Hanuma.
Welcome to PASS Summit 2020. I am Hanuma Kodavalla, a technical fellow in Microsoft and an engineering director in SQL Server engineering. I'll be giving the keynote address. Rayleigh Wong, one of our engineers, will help me with demoing a feature. Asad Khan, my fellow director, asked me to give this keynote presentation. I accepted with great enthusiasm because I have been working in relational databases throughout my career for more than 30 years, out of which almost 25 years I have spent working on SQL Server at Microsoft and Sybase. Asad asked me to give a history of the SQL Server evolution from its beginnings at Microsoft to today's offerings both on-prem and in the cloud. As such, my talk will not go into any technical details, but it will give a description of some of the landmark developments in SQL Server's history. I want to take this opportunity to celebrate the accomplishments of hundreds of engineers and researchers that have contributed to SQL Server's development over the past 25 years. I also, on this occasion, want to express our gratitude on behalf of SQL Server product development groups, our gratitude to you, our customers who have embraced SQL Server and entrusted their most important asset, which is the data. First, I want to start with a story, actually a story within a story. I started at University of Massachusetts at Amherst my graduate studies in computer science in 1985. That year, I read an autobiography, Adventures of a Mathematician by Stanislaw Ulam. In its prologue, there was a sentence that I still remember. It is still an unending source of surprise for me to see how a few scribbles on a blackboard or on a sheet of paper could change the course of human affairs. Ulam was a mathematician born in Poland. He immigrated to the United States with the help of von Neumann, studied at Harvard, and became a professor of mathematics at the University of Wisconsin at Madison. Even though he was a successful academic mathematician, Ulam was feeling that he could do more in those times. It was the time when the world was gripped with the Second World War, and Ulam wrote to his friend again asking for help in finding a better job than just being an academic. So von Neumann found him a job. So a few months later, Ulam got a letter saying that he has a job to investigate the interior of the stars. That was the description of the job. And the job was in New Mexico. Ulam didn't even know where New Mexico was. He went to the library, took a guidebook, and then traveled to Albuquerque, joined Los Alamos National Laboratory to work on the Manhattan Project. Went on to make seminal contributions to the development of the atomic bomb and the hydrogen bomb. On a side note, he was also the inventor of Monte Carlo methods, and he was one of the early pioneers in predicting and actually making use of the computers for complex calculations. So you might be wondering why I am quoting a mathematician in the talk on SQL Server. Just before finishing my graduate studies, I also read two important papers. One by Ted Card on the relational model, and the other by Jim Gray on database systems development. Jim Gray's work was basically a summary of all the work that was being done at IBM in bringing the relational model into practice. These two papers basically describe the two jewels of relational databases, which are the power of the query and the virtue of the transaction. These have stood the test of the times. It's also the 50th anniversary of Card's paper. So it's important to remember that despite many developments, technology trends, the relational model has been popular. And if you look back throughout the history of database systems, there were many alternatives. There was network model, there was XML, there were object-oriented systems, and of late there are NoSQL systems. But you can see that relational database systems are the ones, the most general purpose systems that are used by a variety of applications. Even though other models and systems have found their niche, it is the relational database systems that rule the world. So you might be wondering that I am resorting to hyperbole when I compare the impact of nuclear bombs on human history with relational databases. It is true that a common person knows what an atomic bomb is. They would not know what a relational database is. But anytime one is swiping a credit card or clicking on the internet to buy something, it is actually going through one or more relational databases. Whether you work at a school, at a hospital, at a bank, at a government organization, or a scientific organization, in the modern world, there is always one or more relational database systems powering all of these organizations. Without relational database systems, modern society will come to a grinding halt. So I hope my comparison in terms of the impact is not misplaced. Clearly, the work of the pioneers has been recognized in our field, and they have been awarded with the most prestigious award in computer science, the Turing Award. If we just remind ourselves of the Turing lectures by Card and Gray, the relational database Card proclaimed is the practical foundation for productivity. Productivity for both application programmer and the end user. Application programmer doesn't have to worry about numerous concepts. There's one concept that one has to understand. And end users can query. In the past, end users were not able to query. They had to request someone else to write a program. This theme has held up well. And similarly, Gray has actually, in his Turing Award lecture, given us a set of problems to work for the long term. Build trouble-free systems. Trouble-free meaning systems that are used by millions of users, but administered by maybe one person working part-time. Secure systems, so that only secure users are accessing the system and no information is stolen. Systems that are always up. Gray's goal is a very ambitious goal. Systems should be almost always be available, maybe unavailable for a second in 100 years. These themes are enduring themes. They have kept our field, which is a mature field, but these themes, in face of ever-increasing data sizes, in face of large number of transactions, almost every activity going through a transaction system, has kept our field vibrant. And these enduring themes are what keep people working on databases motivated, and they keep our work intellectually stimulating. Now let's look back at the state of the industry in 1995, when there were many players in databases: Oracle, IBM, DEC, Sybase, Informix. Microsoft was not a player. It was a PC company actually reselling Sybase SQL Server. But it was the time when the so-called killer micros were changing the computing's landscape. Many computer companies were going bankrupt. In fact, DEC was going through hard times and sold its database business to Oracle. DEC had a very successful product called RDB. And as a consequence of that, three senior engineers from DEC, Peter Spiro, Dave Campbell, Hal Berenson, joined Microsoft. Another researcher, Dave Lemay, who was working at Cambridge Research Labs at DEC, also joined Microsoft to establish the database research group. The reason I mentioned the database research group is Microsoft has established a very powerful database research group consisting of luminaries in the database systems, and it has become an extension of SQL Server product group. And almost all the innovations that I will talk about, the Microsoft Research Group has had some role in getting them into the products. Now, in 1995, Microsoft decided to get into databases in a big way and bought the SQL Server source code from Sybase. So that was the beginning of the journey at Microsoft. Peter, Hal, Dave, under the leadership of Paul Flessner, assembled an engineering team and decided to re-architect SQL Server, rewriting both halves of the system, storage engine as well as the query engine. They made some fundamental changes to the architecture, like changing the page size from 2K to 8K. And they implemented what's called dynamic locking, basically row locking, as well as page level locking, but the system will dynamically choose what is appropriate. This is a significant feature, and in fact, this probably motivated the people to re-architect, because at that time, packaged applications like SAP and PeopleSoft were running on Oracle, and when they wanted to run on other database systems, they encountered significant problems because, for example, SQL Server had only page level locking. Other important contributions were the recovery system was rewritten using Aries-based recovery, and new join algorithms were implemented. Finally, a major feature of SQL Server 7.0, and this is an enduring theme for SQL Server product, has been the system must be self-tuning. Prior to this, there were so many configuration parameters that the DBAs had to set. But with the introduction of SQL Server 7.0, it would automatically update the stats. It would figure out how much memory to give to queries, to various other components, and how to actually do buffer pool management, what kind of indexes to be tuned, and so on. So this has been an enduring theme for SQL Server throughout its history. Quickly, 2 years later, we released an enterprise version, and SQL Server started scaling up to a large number of processors, large amount of memory. We implemented several features to actually support data warehouse workloads. It's interesting, when 7.0 came out, the database industry, other players at least thought, well, what did Microsoft know about enterprise systems? But very quickly, SQL Server gained traction in the industry because not only it's able to scale, but compared to other database products, the total cost of ownership has dramatically reduced. And this established SQL Server as a major product in the industry within just a few years. And then 2005 was a major release as larger workloads started moving to SQL Server. We had to take into account the high availability and concurrency control. For example, with locking-based concurrency control, readers were blocked by writers. So we did multi-versioning so that readers and writers do not block each other. Similarly, the tables were getting large, and if we were to build an index, it would block all the readers. So we implemented a major feature called online operation, and this is actually a beginning of making sure all our utilities are done online without blocking other operations. And we improved the availability so that we can open up the database before undo is complete. In 2008, the database were becoming large, and we started implementing various compression mechanisms so that the database sizes are small so that they occupy not only less space on disk, but the actual processing is also has become more efficient because now you have smaller amount of data to deal with. We implemented change data capture so that you can actually take the changes from SQL Server and feed into other systems, say data warehousing systems. We supported spatial data types, improved parallel query processing, and we actually started taking security in a very serious way by implementing transparent data encryption, where data is encrypted on disk so that even if the customer loses or someone steals the disk containing the database, they won't be able to get to the actual data. 2012 was a major release improving our high availability. Technology called Hadron was introduced, and that became a foundation not only for future releases, but also for our cloud products later on. There is a hard standby to take over if the primary fails, and the hard standby was not sitting idle. You could actually use it for queries as a readable secondary. We introduced indirect checkpoints so that checkpoints do not increase spikes in I/O, as well as it will also help us to reduce the recovery time. The other major feature that we did in 2012 was support for column stores and do vectorized query processing to basically give an order of magnitude improvement in query performance. So here I want to take a minute and describe what was happening in the industry at that time. Stonebreaker, who is a luminary in our field, in 2014 Turing Award winner, in those days, he was proclaiming that the main database vendors, IBM, Oracle, and Microsoft, by now people recognize that we are actually a major database vendor. He said they don't innovate, and he also made a claim that you need different databases for different workloads. He wrote a paper called One Size Fits All, an idea whose time has come and gone. We took a different path. We always wanted to make sure once you trust your data to us, you can be rest assured that we evolve with the technology and you don't have to go and resort to going to some other database system. So a lot of the advances that you will see, other people might go and develop other products, but we wanted to make sure those benefits all accrue to the existing customers because we wanted to introduce them into SQL Server so that all the other enhancements that have been with SQL Server immediately are accruing. In 2014, we supported what is called extreme OLTP, so that if we have certain tables which will fit in memory, then we can actually improve the transaction performance by an order of magnitude. And here again, we took a different approach from other database vendors like SAP HANA, who also made use of main memory, but they said the entire database, not just a table, should fit in memory, which requires significant cost to the customers because an entire table to fit in memory means you need to have hundreds of gigabytes or even terabytes of memory. We further improved the online operations by introducing low priority locks. Azure was becoming popular, so we started supporting backups to Azure. And as I said, In the previous release, we introduced column stores. In this release, we actually made those column stores updatable so that we can actually run industry standard benchmark like TPC-H, and we published the 10 terabyte TPC-H benchmark for the first time. In 2016, we added a lot of security features, always encrypted, dynamic data masking, and row-level security. And we also added a major feature called query store. Even though the query processing has advanced significantly, as the workloads kept on becoming very complex, there are always certain queries where the plan that the optimizer has chosen may not be optimal anymore because a lot of the changes have happened to the underlying tables. So query store basically keeps track of the previous plan so that if a plan has regressed, it can look into the history and pick up one of the previous plans that might be better suited. We supported integration with Hadoop, R services. We added temporal tables and in-memory technologies for both OLTP and data warehousing. We continue to invest and improve. And in fact, we published 30 terabyte TPC-H, which was the best in the industry at the time. And I believe on SMP it is still the case. And then in 2017, we continued to improve on making sure that our utilities like index build and index create are online. And further, as the database were becoming large, tables were becoming large, an index build may take a long time and it may crash. Rather than starting from the beginning, we started supporting resumable index build and later on even resumable index create, which I think is the first in the industry. We started making some enhancements to query processing so that at runtime, while executing the query, we can see that some of the decisions that the optimizer had made may not be the right decision. So for example, we can look at the sizes of the intermediate results and dynamically choose a different join operator than what was chosen at compile time. We could also see how much memory was originally given, but based on the runtime data, we can actually change that. So some of these features like memory grant feedback were added as part of this release. And you can see that within just 4 or 5 years, we started dominating on the data warehouse workloads. If you can look at TPC-H benchmarks, we dominate from low end, from 1 terabyte to the highest 30 terabyte on a single node. This is also the release where a landmark development has happened in SQL Server development, and that is shipping on Linux. So let me take a minute to describe how that came about. For many years, SQL Server, and people have asked, would you support on Linux? But throughout its history at Microsoft, since the company and the even SQL Server group was focused on shipping on Windows, we didn't seriously consider shipping on Linux, but things started changing. And let me give a brief background on what was happening within Microsoft. In 2011, a team of researchers led by Galen Hunt from Microsoft Research published a paper called Rethinking the Library OS. What they were trying to do was, the virtual machines had become very popular, but they added significant overhead. So they revived a concept called Library OS, which was discussed in the research community in 1990s on how we can actually have security isolation, application compatibility without having as much overhead as having a complete VM. And this team of researchers reasoned that the application depends on what is called a personality of OS. And all of that personality of OS can be run in the application's address space. Then what you are left with is there is a set of services that the host operating system needs to provide. like sharing of the hardware resources and the respective drivers that are needed. And the library OS where the application runs, it depends only on a small set of OS abstractions like threads, virtual memory, and IO streams. So the research team created this prototype called Drawbridge, where they actually could show that many applications from Microsoft, some of the Office applications, could actually run on top of a thin layer of what is called an platform abstraction layer, so that these applications do not depend on a lot of the operating system services. So that was what was happening in Microsoft research. In fact, if you look at the paper, it says Microsoft doesn't intend to productize Drawbridge. So around that time, there's an engineer, Slava Oaks, who is a distinguished engineer in SQL Server now, and he's one of my peers as a director in SQL Server engineering. He was actually originally a SQL Server engineer, but in 2006, he left SQL Server to work on an advanced operating system. In 2014 or 2015, he came back to SQL, and then he took a careful look at Drawbridge and said, well, why can't I actually look at SQL, which is obviously a much more complex and enterprise application, and see if I can create what is called a SQL platform abstraction layer. And that is how he invented SQL PAL. And out of that, he created the SQL PAL architecture. So you can see that from Drawbridge, they basically said the library, the so-called library OS, it depends only on a narrow set of APIs that the underlying operating system needs to provide. So in this picture, you can see there are about 50 API calls that SQL PAL depends on the underlying operating system. So then he said, well, why can't we go and actually write a host extension for Linux that maps these 50 calls to the underlying Linux kernel. So once he has done that, you could run not only SQL Server, but all the tools associated with it on Linux. And that is how SQL Server on Linux was born. Slava continued this effort to actually take in the other direction of running SQL Server on very small devices. With the revolution of IoT, we started seeing devices being embedded in physical world, in cars, in homes, in factories, and maybe even in human bodies. So what Slava's team had done is, with this SQL PAL technology, they could actually go and run SQL Server on other platforms like ARM64. So 4 or 5 years ago, even within SQL Server engineering, if someone said SQL would run on Linux, people would have been skeptical. If anyone said SQL would run on handheld devices, people would have laughed at. But here we are in 2019. SQL is not only a strong player in Linux, but it's also running on handheld devices. And SQL Server on Linux, if you look at the benchmarks, its performance is on par with SQL Server on Windows, and in some cases even it is actually exceeding. So that is a major development in the journey of SQL Server, and Slava and his team has made that possible with the help of MSR. In 2019, we enhanced query processing by making it intelligent in the sense not only have we improved adaptive query processing, we also started adding what is called approximate query processing, because as the databases are becoming large, you want to get the query response time to be much shorter, even if it means the results may not be accurate, may not be exact, but approximate enough for you to explore. We supported big data clusters, and we also have 100 terabyte TPCH, even though we have not published it, it's running in the lab. that is the highest TPC-H benchmark on a single node. So while this is happening on-prem, there is a development happening within SQL Server organization to understand how we should support databases in the cloud. After a few attempts, this team came to the realization that SQL is very successful. It is a popular language. So we should actually support, we should take the SQL Server technology and offer database as a service. And they have successfully shown that it is viable. And we started actually merging the two teams. And from 2010 onwards, we operate as one engineering team shipping on-prem releases as well as managing this SQL Azure service. As the cloud business started growing, initially the databases were maybe tens and then hundreds of gigabytes. But people started seeing the benefits of the cloud and started moving even more complex workloads with terabyte databases. We quickly saw that it is going to be a problem with the current architecture because thanks to the cloud technology, customers are dynamically upgrading or downgrading the SKUs. Maybe during the weekend, they don't need as many cores as they need during the daytime. So this is something that they probably never do if they were running on-prem. But they're doing it in the cloud. So we need to understand how we are going to actually support that kind of functionality on very large databases. So we started a project called Hyperscale where we decoupled compute from storage so that we can still give the full elasticity and we can support very, very large databases. As we started operating the service, we found a lot of concerns with respect to storage. For example, database critically depends on storage system in terms of when we ask the storage to write a page to disk, and if it has written, it better be telling that in true form, because if it hasn't actually written persistently, then it will cause issues for our recovery. But unfortunately, we have seen some of the SSDs were not honoring the write request that the SQL Server issues. But since we are actually managing the database, and when we detect these errors, we have to make sure that we are recovering the database so that the database doesn't get corrupted. So we implemented what is called write page recording, where when we try to write to the disk, we also note down somewhere else saying, okay, this is the page with this LSN that we have written, so that later on, if we see that when we try to read it, if the LSN does not match, we can go to the backups and restore the page and apply the log. Another piece of technology that we developed just based on our experience is in the cloud, we are shipping on a very frequent basis. Every month there is a new payload that is getting deployed. And there are hundreds of engineers that are contributing to SQL Server. Inevitably, even though we do extensive testing, some regressions do happen. So how do we actually fix those bugs? So we came up with a technology called hot patching. This is done with the collaboration of operating system groups, dev, where if we find a simple bug, one-liner, we can actually create a new build and deploy the new build to a running system without stopping the workload. We also did implement features to improve the elasticity and security. I will talk about them in a minute. One of the major advantages of cloud is elasticity. And this is something that people have quickly realized. It's not available on-prem, but in cloud, they see that there is during the weekdays, you're making use of a lot of resources. During nights and weekends, you're not. Wouldn't it be nice if you automatically scale? There is a nice analogy someone said, if buying your own hardware is like buying your car, renting a VM in cloud is like renting a car. Using database system only when you need is like getting a ride from Lyft or Uber. That's a nice analogy, and basically SQL Azure Serverless provides the same functionality where it recognizes based on the workload demand how to scale up or scale down, and we bill you only for you pay only for what you use, and all of this is managed automatically by SQL Azure. Security has been a critical feature that we spent enormous R&D, and there is not one or two features that will give you the security for the database product. We strongly believe in defense depth. There are many layers of security that Azure provides. First of all, even outside of the database, the network provides security. And we have what is called Azure Defender for SQL, which actually monitors the connections that are coming to the SQL, and based on what IP addresses they are coming from, it can detect anomalies and warn us if some intruder is trying to access SQL. And then there's a bunch of features that we have done within SQL. Not only on the core RDBMS, but also on how we operate. I want to give you this example because this will give you a sense of the kind of innovations we do. Definitely, there are certain things that we do based on our understanding of the technology, based on what we hear from you in terms of the gap in features. But here is an example which came based on operational aspects of the database in the cloud. So this was the summer of 2019. In fact, it was the closing weeks of our fiscal year. I vividly remember we were trying to renew a contract from one of the major banks to basically bring on more workloads to the cloud. Around that time, there was a major incident in the news. One of the US banks, which was running on a cloud provider, not Azure, due to one of the employees having access and then leaking that out, some of the customers' data was leaked out, and it was in the news. So the customer we were working with, they were very concerned because here are the databases that belong to the bank, but they were actually running in the cloud, and the customer was very concerned. How do you make sure that one of the SQL Server engineers who manages this is not taking customers' data out? We have a lot of controls within our engineering organization on what kind of access engineers have, and all the code, all the configuration changes that go through extensive reviews. But the customer was not satisfied. In fact, they did not renew the deal, affecting our fiscal results at that time. So we wanted to closely work with this customer and make sure that we come up with a solution that satisfies and that addresses their concerns about customer data leaking out because of possibly a rogue employee in our organization doing something that he or she was not supposed to do. So we came up with this technology called customer lockbox workflow, where so basically the customer's concern is database is a complex product. There are complex applications running on it. And typically some problem or other happens and they call an engineer, and an engineer may have access to the database, and now they might run the queries and actually get confidential data out. So that is the concern. So the technology that we developed is if there is a support ticket, customer opens a ticket, and then a support engineer is assigned to it. And if that requires product group to be involved, then it comes to the product group. Then what we have developed is we actually incorporate the customer in this loop. So when an incident like this comes up, before giving access to the database, the customer we have to get the approval from the customer. And this access is temporary. And all the operations that the engineer does, let's say some query is not performing well, and maybe we have to increase the amount of memory, or maybe the database running out of space, we may have to add some files. All such operations are audited, and they're actually given to the customer in real time. Further, we also made several enhancements to the database so that this kind of access to the database will only be able to see some metadata, but not actually any customer tables. So this is an example of the technology which came about because of our listening to the customer and working closely with the customer, as well as several product groups within Microsoft. Here is another example of a defense in depth, where we actually developed an advanced technology within core engine of SQL Server. SQL Server provided always encrypted for many releases. You can actually have a set of columns as encrypted, for example, social security numbers or credit card numbers could be encrypted, and they will be stored encrypted on disk, they will be encrypted in memory, they will be encrypted in transit, and only the client will see in plain text. So this functionality existed for a very long time, protected confidential data. But one problem with this technology is you can only do minimal operations on such columns. You can do exact match, but you cannot do complex queries. So one of our researchers, Raghav Kaushik, who was working actually in Microsoft Research, he's interested in this problem. This is actually not a solved problem even in research even today, which is how do you support complex SQL operations on encrypted data? So Raghav was interested in solving it. He actually transferred to the product group, and we decided to start a project where you could actually support complex SQL operations through a technology called enclaves. So what this does is there is a region of memory called enclave that is accessible only to some part of the engine code base, and that memory is not accessible to anyone else. It's not. I mean, even if you attach to the memory, you won't be able to access that piece of memory. So that's called enclave technology. And with that, now we can support more complex operations like comparisons, joins, and so on. So this is still an evolving technology. This is an example of where someone has an idea, and in this case, Raghav from research, and it was not clear if he will succeed because it took almost 3 years. It required a lot of new technologies to be developed, not only within SQL, but also in operating systems. But we said, this is important for us, this is important for our customers, and we need to keep advancing our security technology. So after 3 years, we are actually able to ship it. This is a great example of not only we invest in short and medium-term features, but we also invest in long-term, bold initiatives, even if the success is not guaranteed. Finally, I want to talk about a new area of technology that came into the mainstream a few years ago. There's a lot of talk about cryptocurrencies, bitcoins, and so on, and people started looking at, is there any way to make use of the underlying blockchain technology to automate complex business processes where there are multiple parties involved? So one of our engineers, Yates, was interested in this, so we asked him to go and explore, and he and Jakob, one of our program managers, went and talked to various customers. And the technology was fairly complex because it's a distributed systems technology. Many players were involved, and it was not taking advantage of the current investments the customers have. So we came up with what we call ledger technologies, where we can actually provide proof that the data was not tampered, and we can actually show a historical record of all the changes that happened in the database through cryptographic proofs. And all of that we can support in the SQL that our customers have been using and they like it. So let me now give it over to Rayleigh to give a demo of this feature that is still in development, but we are confident we'll be able to release it in short order.
Thank you, Hanuma, for the introduction. I'm Riley, and I'm an engineer on the SQL security team. I'm going to show you a demo showcasing a scenario for these ledger tables. Here we have Contoso. Contoso is a car company, and they use a software system to track all of their car parts and their life cycle. Bob owns a car made by Contoso, and Bob has a collision. Bob learns that Contoso announced a recall on brakes before his accident, but he was not notified about the recall. So Bob files a lawsuit against Contoso because he believes his brakes were defective. The problem is, Contoso needs to prove they did not use recalled parts in Bob's car. This is a difficult problem. Since Contoso owns the data, their DBAs and highly privileged users can modify it without leaving a trace. Here we see Contoso's parts table. This table has information like the part ID, the batch ID used for recalls, and the car ID. Here you see we're enabling the ledger functionality on this table. We'll create some simple stored procedures to insert a row to the table when the part is manufactured and to update it when the car is assembled. Here we'll manufacture a few car parts. We'll pay special attention to ID 1 since that will go into Bob's car. Here Bob's car is being assembled, so we'll assign the part to his car. When we query the parts table, we see that this looks like any normal SQL table. We have our car part with ID 1 assigned to Bob's car. With the ledger functionality, we get additional information about this ledger table. We see the history of all the transactions that updated it. Here we see the 3 inserts and their ledger transaction IDs. We also see the update, which shows up as a delete then insert, which assigns this part to Bob's car. Contoso will periodically generate database digests and store these in an immutable location, such as Azure Storage Immutable Blobs. These digests have information like the database name, a hash representing the cryptographic state of the database, and other information like the last transaction commit time and the time the digest was generated. With the ledger functionality, there are also 2 system tables. Here, in Sys Database Ledger Transactions, we have each of the transactions that updated a ledger table, along with information like the user that performed the update and a hash representing that. We also have Sys Database Ledger Blocks, which represents groups of transactions and forms a blockchain in our database. When the lawsuit happens, Contoso will need to gather their digest and perform a verification on their database. Here we see that the ledger verification was successfully completed up to block 0, our first and only block in this case. What this verification does is verifies that the blocks form a blockchain with their hashes, that the transactions done to the ledger tables hash to these blocks, and that the transactions we have from our parts and the history tables match up with the cryptographic transactions we have persisted in our system tables. Since this ledger could be successfully verified, the authorities would then just need to query the table and see if Bob's car part was involved in a recall. Here, we show a positive case where there is no tampering detected within the database. However, if a malicious user wanted to go in and modify the underlying data, bypassing all of the SQL Server layers, this is possible for a highly privileged user. Here we see that the data has been tampered with. We've modified the batch ID assigned to Bob's car and assigned it to a different batch, which may not be involved in a recall. Here, even when we run dbcc checkdb, the normal way of detecting inconsistencies in databases, we see no errors are returned. However, since this was a ledger table, when the verification is ran now, we see that the computed hash for the parts and its history table does not match the hash that we've persisted in Sys Database Ledger Transactions. In this case, there would need to be more forensic investigation done to see how this data was tampered by the malicious user. This shows the benefits of using ledger tables to detect tampering in a database. Thank you.
The next few minutes I want to spend on how our engineering has transformed in the cloud era. We invest significant amount of R&D and hardware resources to collect enormous amount of telemetry about the databases that we are managing. Of course, we take great care to make sure that we are only collecting information that does not contain PII. It goes through several reviews to make sure that we are only collecting information about system behavior and system health. But that helps us, that is very large, that is granular enough for us to give guidance on what features to build. It also helps us enormously, even as we do the designs. Several times during the design discussions, we say, okay, let's go and get the telemetry to figure out of the design choices we have, what is the most appropriate one. So this is something that is new. I mean, we have been shipping SQL Server for more than 20 years. And of course, we get feedback from you customers. But it's not easy to understand exactly how the system is behaving. Whereas in the cloud, we have enough information about what kind of queries are running, how complex they are, how many joins are there in a query, how many updates are happening, what's the size of intermediate tables. It's enormous amount of information that is available through telemetry that's helping us to choose the right designs and also to choose what features to develop. In the past, it used to be the case that if we have internally in our labs to run all our functional tests, it used to take multiple days. Now we actually, not only we build SQL multiple times a day, we run millions of tests every day on every build. We use literally tens of thousands of machines in Azure Cloud for our engineering purposes. Previously, I remember I used to run on-prem releases for many years. Many of my engineers used to say that, Hanuma, if only I can deploy my feature and get some feedback, that will be excellent. Of course, there was no way for us to do that because we used to ship our releases every 2-3 years. So if an engineer missed shipping in one release, then they had to wait for another 2-3 years. Now, every month we are deploying, and if an engineer wants to ship a feature, we tell the engineer, go ahead, ship it, but make sure that you have tested it well because there are 5 or 6 million databases running in the cloud, and it's our responsibility to make sure that we don't break any of the applications. So we do deploy on a monthly basis, and we follow a rigorously defined safe deployment policies. First of all, the build goes through a lot of functional and stress tests. We first deploy in what we call stage clusters, and then we go to what are called pilot clusters, where we only deploy to a small number of machines. We observe for a few days, and then we go to slightly larger clusters, and then we go to a region, and we wait for a few days. Only when there are no issues, then we go worldwide deployment. All this time, we are constantly monitoring the health signals from all the databases, and if there is any problem, we roll back or we do hot patch. The service is monitored 24/7 by engineering teams. Of course, there's Microsoft support teams, but the product teams are monitoring the databases 24/7. We have teams distributed worldwide in different countries. And a huge change in engineering is if there is a problem in the service, we call this live site. If there is an incident, then it becomes a top priority at all levels, from new hire to executive, technical fellows, VPs. if there is a live site, then you drop everything you're doing because there's probably a customer that is affected. Every day we review all the cases and incidents. Each team does it, and at larger teams, we review on a weekly basis. For example, I review in many areas, I review once a week what incidents have come. And based on that reviews, we actually come up with improvements and repair items, because our goal is to make sure that the service is running smoothly. But as the service grows, I mean, every day we get more databases under our purview, and different complex workloads are coming. So the new problems keep showing up. But we make sure that we are improving on every week basis. And as we do deployments every month, our goal is to make sure this month's deployment is better than the last month's deployment. There is enormous focus on fundamentals, making sure the service is healthy. We gather customer satisfaction surveys, and these are reviewed in Microsoft at the EVP level. And another big change is now we are deploying every month. We have proof to show what features are working well, what features are solving what problems. So we can decide based on the feedback and based on our experience in the cloud, whatever is working well, we package it up and ship it to on-prem. So the on-prem releases themselves, their quality has increased significantly. So that is a major benefit of cloud-first engineering. So these are some of the key takeaways or key changes that have happened thanks to our focus on cloud. So now I want to take a few minutes and give an example of how we made use of cloud engineering in shipping a significant feature. This is called accelerated database recovery that got shipped in 2019. And I was intimately involved in this feature, so I can give detailed background on this. I spent most of my years at Microsoft working on-prem releases, but around 2015 or so, I transitioned to the cloud. So after just a few months or so, as I was getting to know how we operate in the cloud, as I said, we review the incidents on a weekly basis. So one of the things that was showing up was from telemetry or from incidents, the recovery time for certain databases is unacceptably large. And then when we looked into, there are many cases where there were long-running transactions. Customer issues some transaction, goes out for lunch, or in some cases even goes on vacation. Now that's holding up other activity. Log doesn't get truncated. If there's a crash, now there's a lot to recover. So in a meeting, I remember my colleagues, Thomas Delius and Peter Collin, who were the chief architects and pioneers in bringing SQL to the cloud, they had a lot more experience than me in the cloud. And my reaction was, well, you're not supposed to do these long-running transactions. And I was somewhat complacent. And Peter and Thomas said, hey, Hanuma, we are managing the database, so you better do something about it. So I took that feedback and went back and worked with some of the veterans of Microsoft SQL Server, because this is a fundamental architectural change. And then we came up with a new design where we actually create the versions in persistent store so that if the system crashes or the transaction rolls back, we can do that instantly and recover. So it took us almost 3 years of development, and I vividly remember the nervousness I had when we were trying to deploy, because it's not an ordinary feature that someone puts in a database. Concurrency control and recovery are fundamental features in the guts of the database engine. Once you do them, you're kind of stuck with them. Here we are changing recovery, and And typically, if you're doing on-prem, you send it out, and then maybe a few customers upgrade to the new release. When all of you have had this experience, it's not like big customers will immediately take on a new release and upgrade their mission-critical workloads. But here in the cloud, as I said, we are deploying every month and literally have millions of databases. So we started deploying this critical feature, and this is being turned on by default. I mean, one of the advantages of cloud is we in engineering can say, okay, this is beneficial, so we are going to turn it on. If there is a problem, we take the responsibility. So we started deploying it, and then we faced some issues, and then we realized, okay, a great benefit of operating cloud at scale is we have deep understanding of the workloads, and what we might think as corner case when you're running millions of databases, it becomes an important case to consider and make sure the design handles it. So it took us almost 3 months roll out, turn it on in certain workloads to get feedback on how we are performing. And if we find some issues, work on them and then proceed. So within 3 months, we were actually able to roll it out worldwide. And almost 3 million databases were running with a new recovery subsystem in a database system. That is something I can say no other database in the industry has done it. And now we are in 2020, we have more than 5 or 6 million databases running with this feature turned on. Recovery time has significantly reduced. We aggressively truncate log space, so there's very rarely do we get logful alerts. And once we found that this is working on millions of databases, we had all the confidence to actually ship it as part of SQL 19. I want to conclude by saying what motivates us is the enduring themes that Cord and Gray have had: improve productivity for the application programmer as well as the end user, build trouble-free systems that serve millions of users without having to have customers manage, support small devices to large clusters, support databases from a fraction of gigabyte in size to tens or even hundreds of terabytes, and rely on telemetry. And as we go forward, we'll be making use of new technologies like ML to understand what are the various settings that SQL Server uses and how it can dynamically learn and tune itself, and build trouble-free, secure, always-up systems. So this is what motivates us, and we have bold aspirations. We think that we can serve you better if you actually trust us and bring your workloads to the cloud, because as I have described in the past 10-15 minutes, the way we have been doing engineering has significantly changed for your benefit as well as for our benefit. With that, SQL customers, I want to thank you for this amazing journey, for trusting us, for embracing SQL Server, for critiquing it, and for making sure that we take your feedback and improve. This has been a virtuous cycle, and I hope this will continue for decades to come. Thank you.